Look up at a calm, clear night sky. Now imagine the brightest object in that sky simply blinks out of existence. Instantly, the ambient glow illuminating the nocturnal world vanishes. The reflected sunlight that guides predators and prey alike is replaced by a thick, absolute dark. The cycle of waxing and waning crescents stops immediately. Solar eclipses, created by the precise geometry of the moon passing before the sun, are no longer possible. The celestial ceiling that humanity has watched since our earliest ancestors first looked upward is gone in a fraction of a second. A common misconception is that without the moon, the oceans would surge across continents or sit completely stagnant. Neither is true. This diagram shows the gravitational forces acting on our oceans. The sun exerts its own massive gravitational pull on Earth's water, creating an independent set of daily tides. When the moon is removed, the total tidal volume immediately drops by 50%. This sudden drop in water movement leaves coastal ecosystems stranded. Mangroves, estuaries, and shallow water habitats that rely on deep tidal flushing are suddenly deprived of the water flow required to survive. The ocean's rhythmic pulse, the system that drives global nutrient circulation from the deep sea to the shores, is left muted. Terrestrial and marine biology are tethered to the lunar cycle by evolutionary threads. Entire species use its light and gravitational cues as an internal compass. Newly hatched sea turtles rely on the contrast of bright moonlight over the water to navigate away from the beach and into the safety of the ocean. In the Pacific, the mass reproduction of Pololo worms is synchronized to the last quarter of the 29.5-day synodic lunar month. Without these cues, navigating hatchlings become stranded, and synchronized breeding events fragment. Thousands of species scatter into confusion as their ingrained biological clocks fail. Without the moon, the established cycles of marine and nocturnal food webs begin to unravel. This diagram shows the mechanics of Earth's spin. The drag of the lunar tidal bulge creates tidal friction, acting as a continuous gravitational brake on our rotation. Without that friction, the progressive lengthening of our days is locked into its current rotation. Long before humans understood orbital mechanics, our ancestors built their civilizations around observing these precise celestial rhythms to guide agriculture and navigation. Over 10,000 years ago, the Yoruba people of West Africa developed the Kojota calendar, tracking 29.5-day synodic cycles to ensure their agricultural survival. In Australia, the 11,000-year-old Wurdi-Yang stone arrangements stand as another early example of humanity mapping the heavens to track the passage of time. If the moon had vanished early in our history, early cultures would have lost a reliable reference for the passage of time and the changing of the seasons. Earth's 23.4-degree tilt dictates how sunlight hits the hemispheres, creating predictable seasons. Over long timescales, the moon's gravity keeps that angle locked between 22.1 and 24.5 degrees. As Jacques Lascar's 1993 paper demonstrated, removing the moon causes Earth's axis to sway erratically. A shift of just 1 or 2 degrees in this tilt alters global temperatures enough to trigger ice ages. Humanity survives the immediate loss of the moon, but later generations are forced to contend with global climates that no longer follow a predictable pattern. Beyond stabilizing the physical planet, the moon served as a cosmic metronome. Its reliable cycles provided a template that allowed the human mind to recognize patterns in nature. The 10,000-year-old Warren Field site in Scotland consists of 12 pits designed to align with lunar phases, showing an early ability to record and forecast the passage of months. Centuries later, tracking these celestial cycles produced astronomers like Omar Khayyam, who measured the solar year with an accuracy contemporary calendars could not match. The moon's patterns provided a consistent system for early societies to forecast the future, turning an observation of the sky into a tool for long-term planning. We spend our lives looking down at the Earth to understand human history, yet the architect of our climate, our agricultural rhythms, and our earliest mathematics was orbiting above us the entire time.